Now, let's discuss about symmetric tests. Before this, when I explain on how to sketch families of circle and families of cardioid or lemacon, whenever you see the equation which involve sine function, you should know that it will produce a polar curve which will be symmetric about y-axis. Meanwhile, if the equation involve cosine function, you should know that the polar curve you need to sketch will be symmetric about x-axis. Basically, there is a test that you need to perform to show the symmetricity of the curve, which we call it as symmetric test. If you can look at the slide presentation on page 130, basically these are the illustration that best explain the symmetricity of the curve about x-axis, y-axis, and origin or about the pole. So let's discuss each of the expression one by one. So basically, the first illustration illustrate the situation when you are about to conclude whether the curve is symmetric about x-axis or not. So as you can see from here, this is r theta, and then its complement is actually r negative theta. So in order to show that the curve is symmetric about x-axis, you should show that f theta is equal to f negative theta. If you are able to show that f theta is equal to f negative theta, you can safely assume the curve or the expression given to you will produce the curve which will be symmetric about x-axis. Okay, let's move towards the next expression that explain about symmetricity of the curve at y-axis. So if this is theta, alright, so this is also theta. Therefore, the value here is pi minus theta. This is r theta. This is r pi minus theta. Okay, in order to show that the curve is symmetric about y-axis, we should show that f theta is equal to f pi minus theta. Okay, same goes to like what we have discussed with symmetricity of the curve about x-axis. If you are able to show that f theta is equal to f pi minus theta, you can conclude that the curve that you will sketch based on the equation given to you should be symmetric about y-axis. Okay, let me write something here. Symmetric about x-axis. Alright, so the next illustration demonstrate the situation when you would like to show whether the curve is symmetric about the origin or not. So if this is r theta, so by right, the value here is also theta. Therefore, if you measure your theta in this direction, this should be pi plus theta. Therefore, if you want to show that the curve is symmetric about origin or pole, we should show that f theta is equal to f pi plus theta. So let's try to answer few questions inside the slide presentation. Okay, so as you can see from the slide presentation, the question asks you to show that the curve r is equal to 3 cosine theta is indeed symmetric about x-axis. Hence, they ask you to sketch the curve. In this question, you are given with r is equal to 3 cosine theta. So you should know what is your f theta. F theta is obviously 3 cosine theta. Alright, so you have to look for what is actually f negative theta. So you have to find what f negative theta. In this case, you have to change the original expression from 3 cosine theta to 3 cosine negative theta. If you have your calculator with you, basically we always know that there is an identity that mentioned about cosine theta is equal to cosine negative theta. Or you can use your calculator, which I instructed you earlier. You can use any values of theta and then try to calculate cos. For example, cos negative 45 degree equal to what value, and you try to calculate what is the value for cos positive 45 degree. By right, you will be able to get the same value. Hence, explain cosine theta is always equal to cosine negative theta. By using that fact, you can conclude from here 3 cosine theta. Since f theta equal to f negative theta, therefore r equal to 3 cosine theta is symmetric about x-axis. Alright, so this is the procedures on how you show the curve is symmetric about x-axis. And then the question asks you to illustrate or to sketch the curve based on the function given to you, which is 3 cosine theta. Before this, we know that it will produce a circle which will be center at 1.5, 0, and at the same time the radius should be 1.5, and at the same time the diameter of the circle will be 3, and this will be your circle. Okay, since it is symmetric about x-axis, so the portion of the circle will be splitted into 2 parts, and both of them is divided equally. Okay, hence that is the meaning behind the word symmetric about x-axis. Okay, the portion here is equal to this portion. Okay, if I try to explain in layman term. Alright, so let's take a look at the other example. In this case, you are given with, okay, let us try to do some changes to the equation given to us. Instead of 3 plus 3 sine theta, why don't we try to have r is equal to 3 minus 3 sine theta. If you are given with this equation, the author asks you to determine the symmetricity of the curve, or show that the curve is symmetric about y-axis. You should know that you have to show that f theta is equal to f pi minus theta. Alright, when you have this kind of question, you should know what is your f theta. In this case, f theta equal to 3 minus 3 sine theta. And at the same time, f pi minus theta, so you have to replace all theta with pi minus theta. So the only way to expand the summation of sine, so you have to refer to some sine formula. In this case, I know that sine alpha plus beta is equal to sine alpha cosine beta plus minus cosine alpha sine beta. So by using this formula, you have to expand whatever you have in this with the right way to expand it. So in this case, you will get 3 minus 3 sine pi cosine beta minus cosine pi sine beta. Alright, so sine pi will always give you 0. So altogether here is 0. cosine pi is -1, and then when you try to simplify, you will end up knowing, you will get -3, 3, -1. Okay, let me write it more clear. 0 minus 1 times sine beta. You will end up having 3 minus 3 sine beta. Alright, since f theta equal to f pi minus theta, therefore r is equal to 3 minus 3 sine theta is symmetric about y-axis. And then you can start sketch your curve. In this case, you will end up with this cardioid 3, 3, and 6. Okay, you can always refer to the slide presentation for the accurate cardioid, which is symmetric about y-axis. Let's take a look at this example where you are given with r is equal to 5 cosine 2 theta. Basically, this expression which will produce families of rose curve, which in this case the number of petals you need to sketch is 4, since n is equal to 2 and 2 is even number. So even value for n will produce 2 times n number of petals. So in this case, I'm not going to show to you how to show that the curve is symmetric about x-axis and y-axis. This is one of the example where the equation given to you is symmetric at x-axis, y-axis, and about the pole. So right now, I'm going to use whatever I have inside the slide presentation, where I'm going to demonstrate, or I will calculate to you how to show that the curve is symmetric about the pole or about the origin. So right now, if you cannot recall the formula, by right, you should be able to relate with the illustration which we have discussed earlier, such as, okay, please remember this illustration. If the value here is theta, the value here until here should be pi plus theta. So in order for the curve to be symmetric, you have to show that this expression is true, such as f theta is equal to f pi plus theta. So in this case, f theta is equal to 5 cosine 2 theta. And at the same time, you are trying to look for pi plus theta. So you change and replace theta with pi plus theta. 5 cosine 2 pi plus theta. So in this case, I'm going to simplify it. As you can see from here, I will get 5 cosine 2 pi plus 2 theta. And then I'm going to use some formula for cosine function. In this case, cosine alpha plus minus beta equal to cosine alpha cosine beta minus plus sine alpha sine beta. So by using this some formula for cosine function, I will get from here, yeah, I will get cosine, okay, let me write it, 5 cosine 2 pi cosine 2 pi cosine 2 theta minus sine 2 pi sine 2 theta. Alright, in this case, sine 2 pi will become 0, cos 2 pi will become 1, equal to 5 cosine 2 theta. Since f theta it's equal to f pi plus theta. Therefore, r equal to 5 cosine 2 theta is symmetric about the pole or origin. Okay, right after you manage to show that the expression which is written in terms of polar coordinate is symmetric about x-axis, symmetric about y-axis, and symmetric about the pole, then you can continue by sketching the polar curve, which in this time around we are referring to rose curve with 4 number of petals. Okay, I hope you can do more exercises when it comes to polar coordinates so that you can get the ideas what kind of question we can ask from this topic. I hope you gain something throughout this video and see you around. Bye!